So today's lecture is about beam splitter, another application where MOEMS technology can be implemented. So this is the diagram representing the working of beam splitter. Figure number A is the principle of beam splitter. Figure number B is the beam splitter in operation, and figure number C is the beam splitter in a package. So let's first discuss that what is beam splitter. It is a class of optical device that divides a light beam into two separate beams. It can be a diffractive optic device. It is also believed that beam splitter is an optical version of a copying machine. The splitted output beams can be sent in any direction of interest. Now, coming to figure number A, as you can see that this is the incident light beam. Here we have mirror type beam splitter at 45 degree. Then this is the reflected light beam and this is the transmitted light beam. So you can see that incident light beam is divided into two separate beams. One is going in the right direction, named as reflected, and one is going in a straight direction, passing through the mirror, is known as transmitted. How it works? Firstly, we'll see the figure over here that it consists of laser diode chip. It consists of two lens. It consists of beam splitter, a kind of a mirror at some angle. There's a lens, then photodetector chip, optical path is shown, and then at the end there is a convex lens and optical fiber. Now I'll explain in detail. Full divergence angles as large as 60 degree are possible for splitting light signals that have a wide range of wavelength. So this angle of the splitter varies as per the range of wavelength, but the maximum angle can be 60 degree. In most cases, the beam splitter is generally placed at 45 degree with reference to the source and target platform. If the beam splitter is placed in between an optical path at 45 degree, a portion of incident beam gets through the splitter and remaining portion is reflected at 90 degree, as I have explained in the figure number A, where we are getting the two beam. One is the reflected and second one is the transmitted. So you can see that transmitting is going straight, that means through the splitter, and reflecting is going at 90 degree on the right hand side. Some small portion of the beam which is passed through the splitter is absorbed within the beam splitter itself. It is one of the, you can say that, feature or a property of a beam splitter, that it will also absorb some amount of energy or beam. Because of this feature, the beam splitter is considered as an optical window. It has a metallic or dielectric coating on one side with definitive reflecting and transmitting characteristics. So these are the basic characteristics which is shown here, that it must consist of some metallic or dielectric coating. Then only it will divide or separate the beam, incident beam, into two separate beams. And it should have some reflecting and transmitting characteristics too. The splitters are known as mirror type beam splitters since some portion of energy is in fact reflected from the splitter. The typical reflection ratio varies from application to application. Reflection percentages can range from 30% to 80%. It varies as per application. A time invariant constant reflection to transmission ratio over a large spectral range is desirable. Spectral range means that over a large wavelength of beam which we are using. Beam splitters are very sensitive to polarized light due to the reason that polarization of light is changed when it is incident on a beam splitter oriented at 45 degrees. In a typical mirror type beam splitter, the S polarization state is reflected more than the average amount of reflection, and the P polarization state is reflected less than the average when randomly polarized input light is incident. That's all about the beam splitter. In the next lecture, we will discuss about the micro lens. Thank you. Have a nice day.